Hello everyone, my name is Noatira Tasha. Let's rock and roll in this video tutorial.
Hello everyone, here we go. Let me introduce myself. My name is Tajul Maidin and I am a mechanical engineering student.
Hi, my name is Ahmed Hakim and I'm a mechanical engineering student. Nice to meet you.
Hey, what's up guys? My name is Nurin Faihana. I am a mechanical engineering student.
Hello everyone, let's talk about heat transfer. What we are really talking about here is how energy moves, specifically heat energy, and how it gets from point A to point B, whether it be here on the surface of the earth, up in the atmosphere, or even out in space. Heat transfer occurs in three ways, and these include conduction, convection, and radiation. Let's take a look at each of these, starting with conduction. This heat transfer is as a result of a molecular contact. The best way is to understand conduction is by thinking about an example. So, here I have a metallic spoon and imagine I holding a match underneath of it. Well, we know that the spoon is going to heat up. The spoon is going to heat up, and that is what we call conduction, where the energy from the flame is causing the molecules within the spoon to vibrate, and that is transferring energy from one to the next until the entire spoon has warmed up. That heat is transferred throughout the entire material. Conduction is going to happen most effectively in solid material. This is heat transfer through or as a result of density differences. Again, here is the example. Imagine I have a match, and as we may know, it is not the best idea to hold match above an open flame like this. This is because a lot of the heat energy generated by that flame is going to rise. This purely shows that this is because of process of convection. What is happening here is the flame causing the air to expand, and when it expands, it becomes less than the surrounding of air and therefore floats upwards. Convection most effectively occurs between liquids and gases. Finally, let's think about radiation. Radiation is heat transfer by wave motion. Okay, let's pull up that flame one more time. As the previous explanation, heat is going to rise because of convection, but it is also going to travel outwards in the form of energy electromagnetic waves. Radiation is interesting because it doesn't need material to travel, so this can occur in open empty space. So here is the summary of heat transfer theory. However, in this video tutorial, our group only focus on radiation theory. For further explanation in this theory, it will be explained by Tajul Maidin in the next video. That's all from me. Thank you and have a good day.
Hello, so here we go. The theory of the project. First, the radiation in the heat transfer can occur in between two separated bodies by a medium colder than both the bodies. Second, the radiation gets emitted to all the bodies above the absolute zero. Third, the radiation travels at the velocity of light, which shown below in vacuum, and the wavelength of the formula is as shown below. Fourth, the thermal radiation is the energy that is emitted by a medium by virtue of its temperature that usually travels in a straight line. Fifth, the thermal radiation incident that act on a body or in a medium may be partially reflected or partially absorbed, or the remainder will be transmitted. The formula used for this will be as shown below. Sixth, there is few types of medium that can be considered. First, the opaque surface, which will be the tau equals to 0. So, the formula will be as shown below. Next, black surface, where the perfect emitter and the absorber occur. So, it will be alpha equals to 1, rho equals to 0, and tau equals to 0. The last one will be highly polished surface that can reflect everything like a mirror. For this one, alpha will be equals to 0, rho will be equals to 1, and the tau will be equals to 0. Seventh, the highly polished and smooth surface act like a mirror to the thermal radiation. 8. The emission from a source can be divided into 3 types. First, black body. Second, real material. Third, the grey body.
Hi everyone, it's me Noreen. Let's proceed with the first question to enhance our understanding about this topic. In this question, we assume that the filament behaves as a black body. Black body emits the highest possible rate. It also absorbs all the thermal radiation incidents upon it. The question requires us to determine the fraction of visible radiation emitted by the filament. The formula used is F equals to wavelength multiplied with temperature. In this question, the visible range of electromagnetic spectrums extends from 0.4 micrometer until 0.76 micrometer. Noting that T equals to 2500 Kelvin, the black body radiation functions can be obtained from table 12.2. From this, we can find the fraction of radiation emitted between these two wavelengths. That is, 0.03% of the radiation is emitted at wavelengths less than 0.4 micrometer and 5.3% at wavelength less than 0.76 micrometer. Therefore, only about 5% of the radiation emitted by the filament of the light bulb falls in the visible range. The remaining 95% of the radiation appears in the infrared region in the form of radiant heat or invisible light, as it used to be called. This is certainly not a very efficient way of converting electrical energy to light and explains why fluorescent tubes are a wiser choice for lighting. According to Wien's law, we can find the wavelength at which the emission of radiation from the filament is maximum. This shows that the radiation emitted from the filament peaks in the infrared region. In this question, we can also find the maximum thermal radiation that can be emitted by a surface by using Stephen Boltzmann's law. That's all from me. Now I'll pass to Shamil to proceed with the second question.
Hello, my name is Shahmil Hakim and I will continue for the question 2. Okay, for this question, the view factors between the rectangular surfaces shown in the figure are to be determined. From the figure, we can see that there are 3 surfaces that can produce 4 view factors. The view factors are view factors 1 to 3, view factors from 2 to 3, view factors from 3 to 1, and view factors from 3 to 2. So there are 3 surfaces that can produce 4 view factors. Then we also assume that the surfaces are diffuse emitters and reflectors. Next, we must analyze the view factors. To find the view factors, we must use the figure view factor between two perpendicular rectangles with a common edge. But before that, we must find the ratio L over W for the both surfaces that involve. For first part, we want to find the view factors for view factors F3 to 1. So we must find L3 of W and L1 over W. So L3 over W, which is 1.2 over 4, equals to 0.3. And L1 over W, we get 0.3. Then we bring the both value to the figure and find the view factors. For the x coordinate, we use L1 over W, which is 0.3. Then we connect to 0.3 line, which is L3 over W. Connect and find the intersection. Then we will bring it to the y coordinate to find the view factors for F31. Then we will get 0.26. After that, we want to find the view factors from 3 to the combination surface 1 and 2. It has the same step as before. So the ratio L3 over W is 0.3 and the combination surface ratio L1 plus L2 over W, that will bring us to the value of 2.4 over 4 equal to 0.6. So we bring those values to the view factor table. For the x-coordinate, we take the combination of surfaces L1 plus L2 over W, which is 0.6. Then we intersect to the line of 0.3, which is the ratio of L3 over W. Then we will bring the intersection to the y-coordinate to find the view factors from 3 to combination surface 1 plus 2. And we will get 0.32. Next, we must first consider the reciprocity relation that shows that when AI equals to AJ, the view factors from J to I equals to view factors from I to J. So, in our equation, we note that the A1 equals to A3. For the relation A1 F13 equals to A3 F31, it will give us the same view factors because it has the same area. So F13 equals to F31 that we got before, it will give us F13 equals 0.26. After that, I will show you the superposition rule. Okay, this figure, it shows that the view factors from 1 to the combination surface to 3 equals to view factors from 1 to 2 plus view factors from 1 to 3. So, we use the superposition rules and apply it to our equation. And we will get the view factors from 3 to the combination of surface 1 plus 2 equals to F view factors F3 to 1 plus view factors from 3 to 2. We already have the view factors from 3 to the combination of surface 1 plus 2, and we also have the view factors F3 to 1. So, it gives us to 0.32 equals to 0.26 plus the view factors from 3 to 2. Then we solve this equation and we will get the view factors 3 to 2, which is 0.06. And lastly, we use the reciprocity relation again. We know that the A2 equals to A3. So, the view factors of 2 to 3 equals to the view factors 3 to 2. So, the view factors 2 to 3 is 0.06. And we finally get all the view factors for the surfaces. That's all.